All right, let's move on with the traffic inputs. All right, let's see. All right, so if you look at, so here's a little quick video of the traffic inputs. You can see the traffic inputs are right here. So we entered these after layer inputs, we usually go to traffic inputs. And if you click traffic, double click traffic, you'll see the traffic tab will open. And on the left, you will see AADT, number of lanes, percent trucks in the design lane, and directional distribution, operational speed or vehicle speed, and all that. And also, there's a whole bunch of information about typical spacing of the tandem axles, dual tire spacing, all these things. One more, question for Justin and Adnan. Do you change these very often? I believe
we don't mess with that stuff. We investigated it, however. Let's see. The axle configuration, we briefly investigated. We thought their factors were fine. As far as the lateral wander, we tried to find information on that. It was hard to come by. We found one research report that was a safety report, but it wasn't enough data to change it.
Yeah, so that's very common. Usually people just find some typical numbers for the state and then stick with it. So those are not extremely significant inputs. These are, and of course AADT is.
The AADT section is the primary section.
Yeah, this is the section essentially that you change every single time. So let's move on. So as you go through, it will, if you click on single axle distribution, this is the table that you need to have. This is the axle load, what we call axle load spectra. I'll talk about this later on in detail. If you sort it based on class, you will see how the axle load distribution for single axles of class 4 changes with load level. So this is really a probability distribution function kind of a thing. So you can see for class 5, you have different, for different months, you have different distributions. So we're going to plot some of these. I'm going to plot some of these, and I'm going to show them how they actually look like. Now, so let's move on. So when you look at traffic, this is the general class traffic inputs. There's an axle load spectra. When you double click on the single axle or dual axle, that's going to show up. Vehicle class distribution and growth goes here. Monthly adjustment goes here. Axles per truck goes here. And hourly distribution goes here. So we'll go one by one what it means. Now, general traffic inputs, this AADTT section, as Justin said, this is project specific. This is based on what project you are working on. You need to enter carefully based on what you have. These numbers, typically default values for a region is used, and they're not changed very much. Now, and this is just to clarify, this is average annual daily truck traffic. It's not ADT, it's the truck traffic. So it is essentially ADT, which is the average daily traffic, multiplied by the percent HGV, or percentage of the trucks in that roads. So that's what this is. Now, vehicle class distribution. So these are the FHWA classes, class 4 through 13, and these are the classes that, whatever the class that you have in your state or in your trucks, you need to classify into these classes. And let's say in this particular case, it says 1.8% of all the trucks is class 4, 24.6% of all the trucks is class 5. 7.6% of all the trucks is class 6, and so on and so on. Okay? So this is really, all this needs to sum up to 100. This is the growth. You can choose a linear or nonlinear growth. Okay? So growth rate is 3%, let's say. This is the growth rate R, not the growth factor, but the growth rate R. used in ESOL calculation. In ESOL calculation, you use growth factor, which is a function of R. Now, one thing important is if the weighing motion stations, so weighing motion stations really are key. So if your weighing motion stations does not classify the trucks into these 13, well, these are not 13 actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 classes. 10 classes, then you need to classify them into 10 classes. I've never worked in WIM stations in Michigan. Have you worked on a WIM station? Number of, how many classes the original WIM data classify? 10 FHWA classes, or?
Yeah, we do our best to classify all of them.
No, I mean the raw data of WIM data. Does it classify into 10 FHWA classes or more than 10 original?
We do the same ones that are required, so all 10 of those that are required.
Okay.
Cars.
Okay. The reason why I'm asking this is because I haven't done this in Michigan because my colleagues were doing that work. So, but I've done this in other countries, and they have like 50 classes.
Oh, I see.
So the WIM data, when it comes out, there are 50 different classes.
No, we just use the FHWA classes.
Okay. So the original weighing motion data, in Michigan, is just 10 classes. That's simple, but it could be more than 10 classes. Then you have to map those more than 10 classes into FHWA classes, and that needs to be entered here. So in this case, this is actually from Qatar that I worked on. So they had 48 different classes of vehicles that we had to map to 10 FHWA classes. 48. They have very interesting trucks there. Okay, so axles per truck is interesting. Now, so it's what this says is class 4, let's say. Now, class 5 is, let's start with class 5. Class 5 says there are 2 single trucks, 2 single axles, no tandem axles, and no tridem axles. That's what this means. So class 5, let's go back to the picture. This is the class 5, right? It says it has 2 single axles, okay? And no tandem, no tridem axles. Class 4 has 1.62 axles. Y is fraction, 1.62. How can you have 1.62 axles? Either you have an axle or not, right? How can you have...
Load is more than 18 kips on the axle.
No. So that goes into the axle load distribution. That's a good point, but it is not. So what happens is you can have a bus that looks like this, a single and a tandem. This is a one single and tandem. If all your buses are like this in your area, let's say all your buses looks exactly like this, then you would enter here single, tandem, 1, 1, if all your buses. But if you have buses that has 2 single axles, 1 single in the one in the back. Let's say 50% of your buses are 1 single, 1 single. So you have 2 here, 50%. The other 50% is, let's say, 1 single, 1 tandem. What we do is we really do an average and do a weighted average to come up with a like 1.62 single and 0.39 tandem. That's how this is entered here. It's an interesting input. Okay, I believe I have an example on how to actually calculate this. Monthly distribution. We have a monthly distribution. Original comes with a 1 everywhere, meaning that there's no change. There's no change in monthly, month to month. change in the vehicles. So if it changes, let's say if there are no more traffic in different months than the other months, kind of a thing. But this is obviously not true in most states, so you need to analyze the way in motion data to come up with a table like this. Again, I have an example for this in a minute. An hourly distribution, again, if you have an hourly traffic count data, well, by the way, you don't necessarily need WIM data if you have a traffic count data, but it has to be classified count. So it's a count, but based on classification. So it's classified, sorry, but it's only the number of vehicles, but it's classified, then you can still get this one and this one. I'll show you an example in a minute. Axle load spectra is something difficult to get. You do need weighing motion station for this. Weighing motion station. So you need the weights of individual classes. Weights of individual classes and weights on the axles of individual classes. Now, here's an example WIM data analysis for axle load spectra. So this is from Qatar that I analyzed. From the weighing motion stations, so this is like a class 5, FHW class 5. There they're classifying as class 2. As I said, they had 48 different classes there for trucks, but that was the class 2 that corresponded to class 5. Now, in that weighing motion station, so there was like years of data, lots of data. So weights of those class 5 vehicles are measured, okay? So, and the weights are changed a lot, okay? So this is actually number of times that a specific weight is observed. For example, this is about what, like 30 times this kilogram is observed, 120 times this, almost 200 times or 190 times this weight is observed. This is really a distribution of the weights. Probability density function, distribution of the weights. You can see sometimes there are lots of overweight vehicles on this particular case. You can see, but most of the weights are around this. So the axle load spectra that you enter here for class 5 here, 1.96, 1.18.15, these numbers really come from these. So this is actually a number of occurrences, but if you divide the number of occurrences by the total number of vehicles, you get the percentage. So this comes actually a percentage, and actually this is a cumulative distribution of that. So this percentage corresponds to here. Those percentages are entered in the axle load spectra. This is actually gross vehicle weight. You have to divide this into two axles, and you have to analyze individual axles, but I don't want to get into too many details. This is a tedious job. As a payment designer, usually you don't do this much. You know, somebody else does all this analysis for you and prepare all this axle load spectra, and you pretty much use like regional values for these. Am I right? Or
for our axle load spectras, we derive this from a program called PrepME, which kind of like compiles all the data and outputs it based on the WIM data, what the bid counts are.
Okay.
So